In previous lecture, I have discussed about the basic concept of per unit system, how you will convert any power system quantity from conventional unit to per unit. You must remember the per unit value of any power system quantity A is the ratio of its actual value to its base value. And the second thing is the actual value and base value should be of same dimension. This is very important. So A and AB should be of same dimension, and A and AB will be in conventional unit. So in this way, you can find the value of any power system quantity in per unit. Second thing which I have discussed in the previous lecture is about base value. Base value can be of any round figure. Base value of any physical quantity can be 10, 100, 1000, depends on you. But you have to mention this is the per unit value on base this. So already I have discussed about this concept. And second thing which I have mentioned in the previous lecture is usually the base value is considered as the rating of the machine. So I will also consider the rating of the machine as the base value if it is not given in the problem. And the second, I have derived this formula. Using this formula, you can convert the value of impedance, resistance, reactance, which are given in the conventional unit into per unit. So formula is the value of impedance in per unit will be equal to its actual value, which will be in ohm, into base volt ampere divided by square of base voltage. So you must remember this formula. And based on this concept, today I will discuss some numerical example. But this formula is very important. So now let us consider the first numerical example. Here base impedance and base voltage are given. Base impedance is 10 ohm and base voltage is 400 volt. And the task is to calculate base kVA and base current. So how you will calculate base current? So simply you can use the formula of impedance, and from that formula you can find the value of I. I will be V base by Z base, because you know from the definition of impedance is ratio of V and I. So from that formula you can easily calculate the value of base current. Here base voltage is given 400 volt and base impedance is given 10 ohm. So base current will be 40 ampere. And the second question is calculate base kVA. So base current is known and base voltage is given in the problem. So base kVA will be voltage into current. So here voltage is 400 and current is 40. So when you will multiply, you will get 16 kVA. So this will be the base kVA. So in this way, you can determine the value of base current and base kVA. Now let us consider second numerical example based on this formula, which already I have discussed. This formula is very important. Here you can see the line impedance, series impedance is given. Actual value of impedance is given, which is Z equal to 4 plus J60. And base MVA is given, SV is given. This is base MVA. It is given as 100 MVA. And line voltage, you will have to consider line voltage as the base voltage. So line base voltage is also given 230 kilovolt. And now the question is to convert this conventional unit, this impedance which is given in conventional unit into per unit. So you can use this formula to convert impedance which is in conventional unit in per unit. So here actual value is 4 plus J60. Base voltage is 100 MVA. A base MVA is 100 MVA and base voltage is 230 kilovolt. So you can just substitute this data on this formula. You will get this answer. So in this way, using this formula, you can convert impedance, resistance, reactance, which is given in conventional unit. And by using this formula, you can convert this conventional unit in per unit. Now you must remember here in this problem, SB and VB are given, base voltage and base volt ampere are given. But if it is not given, then just you will have to consider SB and VB from the rating of the machine. So this is very important. When SB and VB are not given, then from where you will take SB and VB? Just you will have to take these data from the rating of the machine. Although in this problem, these data are given. Now, sometime it is required to convert the data from one base to another base. Suppose resistance is given on some particular base, and according to the demand of the problem, demand of the analysis, you will have to convert this resistance on some another base. So how you will convert the value of resistance, reactance or impedance from one base to another? For that type of conversion, this formula will be helpful. In this formula, you can see the per unit impedance is directly proportional to base MVA and it is inversely proportional to square of base voltage. So you must remember this concept. The per unit impedance is directly proportional to MVA rating, MVA, base MVA, and it is inversely proportional to square of the base voltage. So by using this concept, now we will see we can change the resistance, reactance or impedance value from one base to another. So let us see this slide. Here reactance is given on base this. This is old base, or you can say VB1 or SB1 are the base value at which reactance is given. And the task is to convert this reactance on a new base. How you will convert? So as you know, the resistance reactance in per unit can be written as its actual value into SB by VB square. So on base VB1 and SB1, on base VB1 and SB1, the reactance will be its actual value into SB1 divided by VB1 square. And you want this reactance on new base. And on new base, the reactance will be its actual value into new base, which is SB2 now, divided by VB2 square. And when you will divide these two terms, what you will get? You will get this expression. Here SB1 and VB1 are given in the problem, and SB2 and VB2 are the new base at which you want reactance, and X1 per unit is also given in the problem. So by using this formula, you can find the reactance X2 per unit on new base. Let us see this concept through a numerical example. Let us consider this numerical example. Here transmission line impedance is given 0.1 per unit. So given value is X1. It is X1 per unit, which is 0.1. On base, it is given on base VB1 and SB1. This is given on 220 kilovolt, 220 kilovolt, and the base MVA is 100 MVA. Now, the task is to calculate the same reactance on new base. Here, new base is VB2 and SB2. Suffix 2 is used for the new value and 1 is for the given value. So here new base is 110 kilovolt and the new base MVA is 50 MVA. So this is the value of VB2 and SB2. So by using this formula, you can find the value of reactance on the new base, or you can say you can find the value of X2 per unit. Here X1 per unit is given 0.1. SB2 new base is 50. SB1 is old MVA, which is given 100. VB1 is old base voltage, which is 220, and VB2 is new base voltage, which is 110. You can solve this mathematical expression, you will get 2. And now X2 per unit, X1 per unit will be equal to 2. So X2 per unit will be twice of X1 per unit, and X1 per unit is given, which is 0.1 per unit. So in this way, you will get the answer 0.2 per unit. So in this way, you can change the value of reactance from one base to another base. In this problem, you can see the reactance is given on base 220 kV and 100 MVA. And using this concept, you found the value of reactance on the base 110 kilovolt and 50 MVA. So in this way, you can change the base value of the reactance, and it is required when you will analyze the power system. It is the need to change the base voltage, base MVA from one base to another base. So you will see, later you will see this application of this concept in the analysis of power system. In next lecture, I will discuss some basic concept about the transformer reactance. I will show in the next lecture that the value, if you will use reactance value in per unit in the case of transformer, then there are some advantages which you will see in next lecture. So next lecture I will discuss about the transformer reactance in per unit system.